somebody get removed from the meeting. Just check who get removed. I have just seen. So I was talking about the safety walls. Safety walls are made for avoiding the accidents against the explosion of the steam or hot gases. Now, what is the role of fusible alloy? Fusible alloy is nothing but the alloy which are having low melting point. The melting point of that alloy is less than the boiling point of water. So boiling point of water is 100 degrees Celsius. So you may be surprised to see such alloys. You may be surprised to see such alloys which are melting even at room temperature. So the technocrats have defined the list of the alloy. So what is the what kind of questions may be asked in the examination and what kind of question may be asked in the oral or interview? So what are the different fusible alloys? Explain the characteristic of it and enlist a few alloys. Let me tell one beautiful example you might have seen during your childhood. So the juggler means jadugar. So what he's supposed to do, he's supposed to take the coffee cup, and in that coffee cup he's supposed to take the spoon, and he'll take the sugar or the coffee, and he's supposed to put that coffee or sugar into the hot water, and he used to stir. So when he's making the stirring action, there's no problem. The coffee or sugar get dissolved into the hot water. At the same time, when he will remove the spoon, you will find spoon has get dissolved into water. So we people feel ki what kind of magic is this? So no any magic in that. The spoon which is used by that magician is made up of such fusible alloys whose melting point is maybe 40 degree or 50 degree, because hot water, boiling water melting point, I told 90, more than 99 degrees Celsius, because at above 100 it becomes vapor. So if you take very hot water, maybe of 90 degree or 95 degrees Celsius, and if you use the fusible alloy whose melting point is 70 degree or 60 degrees Celsius, and if you put in that water, that metal or alloy get dissolved into that hot water. So this is a part of magic, but what is the science behind it? The science is there are many alloys which melts at very low temperature. What are the applications I told? The applications are in the safety walls, fuses. For example, maybe I have given you the domestic example, like today only in one hour of lecture, you can just see the lid of pressure cooker. I'm not talking about the viscera at the top. At this side, there is one wall. It is called as a safety wall. So that is tied with that such fusible alloys. If there may be chances that your whistle will not work, that is exit valve for the pressure of steam. If it will not work properly, then there may be leakage from that safety wall, which will avoid the explosion of the pressure cooker. Not only about pressure cooking industrial applications, there are many pressure vessels where these such walls are used to avoid the explosion. In the boilers, steams, chemicals, any hot area where the hot fluid is used, such walls are used which are made up of fusible alloys. So there are a number of alloys. You know that the great scientist Newton also has invested one of such alloy. So these alloys are having important contents as bismuth, lead, tin, antimony, gallium, indium, etc., etc. So I will provide one chart to you, and in that chart 6 to 7 alloys are given. Minimum 4 you have to remember, so that you can write in exam for getting minimum 3 marks out of maybe asked in the short notes. So bismuth, remember, bismuth is one of the important alloying, or you can say base. Many times some other elements are more than bismuth. In that case, you can call that element as a base. But every alloy, every fusible alloy is having bismuth as one of the major content. And in this way, we'll see. Now recently, maybe few years back, gallium. You might have heard the metal gallium. So that gallium is used for making the fusible alloy with addition of this bismuth, lead and other element called as gallium, whose melting point is minus 90 degrees Celsius. So at room temperature, it is not solid. Remember. So such fusible alloys are recently developed. When I will show the table, you will find the technocrats have only made little change in the composition. So if anybody of you want to do something on trial and error basis, you can also develop your lab and you can find out the lowest temperature at which your alloy will melt. Okay. So I hope you understand the meaning of word fusible alloy. Fusible alloys are the alloys which are melting at very low temperature and are used for applications such as fuses and safety valves. Okay, write down. So I think whatever I have written on the whiteboard, it is visible to you. So first write down definition. Before I draw the table on the whiteboard, you write the definition. Fusible alloy. These are the alloys which are capable of being fused, F-U-S-E-D, being fused at relatively low temperature. Fusible alloys are eutectic or hypoeutectic. I'll make one table. 1, 2, 3, 4, 5, 6. All right, 1, 2, 3, 4, 5, 6. 7 columns you make. In this way, you'll write alloy, then melting point. The title of second column is melting point. Bismuth, lead, tin, indium, and other. Indium, INDIUM. One minute. Mr. Madne, why are you joining late? Right on. First, here in the alloy. Alloy by Newton. Alloy by Newton. Or instead of that, it will be again lengthy. I will change the title. Wait. So make one small correction. Instead of alloy, you write discoverer. So that directly we can write name of the technocrat here. And alloy number 1, alloy number 2, alloy number 3 in this way. Alloy number 4, 5. So alloy number 1, just write serial number 1. Discoverer, Newton. In bracket 1701. 1701. So almost 300 years back. Melting point, you write 98. 98 degrees Celsius. Content, you write bismuth 50, lead 20, tin 30. So whatever alloy by Newton is on the trial and error basis. He has taken 50% of bismuth, 20% of lead, and 30% of tin. And he made the combination. And after that, he realized that whatever the combination he has taken, it melts only at 98 degrees Celsius, which is less than the boiling point of water. So first, this is discovered by the Newton in 1701. The year of discovery I told. You know, Newton has suggested, given many inputs to the technology and science. So here also he has given his contribution. Okay. Second line, Rose, R-O-S-E. This is again name of the technocrat. 1972. Now, when Rose has played with this combination to get some different melting point, he has made many trial and error experiments, and he found 3-degree drop in the temperature of this alloy number 2. He has given his name Rose alloy. Okay, write down percentage. 50% bismuth. Melting point is 95, 3-degree drop. Bismuth 50%, 27.1% lead, 22.1% tin. Little combinations here and there. Almost 70 years later, 3-degree drop was invented. Then next, D-arset. D-arset, like D-alumbered. D-A-R-C-T. So writing D'Souza, D-alumbered, that way D-arset. 1975, after 3 years. He also got same degree Celsius melting point of this fusible alloy, but with little different combinations of bismuth, lead, and tin. Write down 49.2, 49.2% bismuth, 21.2% tin, 27.6% lead, 27.6% lead. Then after few years, maybe you can say in the next, you can say after the many 50, 60 years, whatever the melting temperatures obtained by this Newton, Rose and Dearset. So almost in the next century, around 1850, one of the technocrat, his name is Onion. Beautiful names are there, Onion, Rose. Next one is Wood. So Onion got 92 degrees Celsius temperature with, so we can, in bracket you can write around 1850, and this 3-degree drop temperature he produced with just reverse combination of Newton. I don't know whether Newton has carried out this experiment, but if you see the combination of Onion with Newton, it is just reverse. So if you put search on the Google Onion's alloy, you will find this combination. 30% lead and 20% tin. 92 degrees Celsius melting point. Then around 1860, wood has achieved much temperature drop, almost 70 degrees Celsius. So far below than this 92, 95. So 20-degree temperature drop is obtained by this wood with the combination 50% bismuth, 25% lead, 12.5% tin, and one more alloy, 12.5% cadmium. In others you write CD. Here, friends, here I have written 12.5% cadmium in the other. In 1935, name of the scientist is French, 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 French. French got 46.9 degrees Celsius temperature, much temperature drop than the wood, Onion. So he has added few more elements, which are these: 41% bismuth, 22.1% lead, 10.6% tin. The result is written here. 21% lead, 10.6% tin, 8.2% cadmium, and here indium is used by him. 18.1% indium. 46.9 degrees Celsius. And recently, you can say in few years back, Galveston, Galli, don't write double Li, Gallinstan, I will write once again. And temperature is minus 19 degrees Celsius, minus 19. And for your kind information, this Galveston is the alloy where base metal is not bismuth. All other technocrats have taken bismuth as a base metal, but Galveston is the name of alloy which is produced by gallium. Gallium in others I will write GALLIUM 69% almost. 69% gallium, 1.5% bismuth, only 1.5%. 10% tin. Lead is not present. And indium is 22%. Just see the percentage whether it is matching 1.12 here there. So these are the alloys called as fusible alloys. Out of these 6, 7, you remember minimum 4 alloys. And remember these combinations. Short note, it will be asked, you should be able to write explanation as well as you have to write the example. An application, just next to table you write applications of fusible alloys. Safety valves, used in pressure vessels, sufficient. Safety valves used in pressure vessels, used in chemical and other gases industries. Wherever your pressure vessels are coming with in contact or they are used for high pressure fluids, gases, etc. And domestic example I have given the safety valve in the pressure cooker. You can see today also at your residence. This is all about fusible alloys, which will be asked for 3 marks in the short note. Okay. Our next bit will be little different than the sequence of these non-ferrous alloys. This short bit is there, which is added in the syllabus under the title Composite Materials and Nanomaterials, which will also be asked. Either composite will be asked or nano will be asked in the exam every time for 3 marks or 4 marks maximum. So these are generally, if you Google, you will get lakhs and lakhs of the pages of the information. But in your syllabus, it is only added as the introductory purpose. If you see, nowadays, lot of research is going on composite material and nanomaterials. But as far as our syllabus is concerned, it will be only elementary treatment. Okay? So you can go to next page and write down the title, Composite Materials. May I erase this? Somebody reply.
Yes.
Okay. क्लास पे गूगल इसमें आना जरा है कुछ तो नहीं है थोड़ा सा ना इसमें Yes. 1 minute. So next title is composite materials. So you might have seen in day-to-day life, there are many materials developed for the betterment of the applications in industrial sectors. What are the need of the society? What are the need of the industries for getting much better properties with less cost and improved properties of the material? Now we have studied alloy. Alloy consists of addition of two or more element. Then A is element 1, base. B is another element called as a solute. When solute is added in the solvent, they get dissolved into each other, which will form the alloy. For example, I told copper is the base, zinc is the alloying element, which form brass as a copper zinc. It is also called as a brass. Now, what is the difference in the alloy and composite material? Composite material also have two or more elements added into it. The major difference in composite materials and alloy is composite materials forms mixture of two or more elements which are not soluble in each other. They are added at macroscopic level. Macro, M-A-C-R-O. Difference in micro and macro. Try to understand. MACRO macro means maximum magnification up to 10x, visible by naked eyes. And micro level means which is not visible by naked eyes. It requires more than 100x magnification. So when you add element A, element B, and element C into each other and forms the composite material, that material will have better properties in the terms of less weight and high stiffness. The best application of composite material which you are observing in day-to-day life is your concrete. So in the concrete blocks, so in the concrete, cement concrete mixtures, stones, sand, cement, water, etc. This material is mixed and then it is poured into the area where already the reinforcement of the steel is prepared. So steel rods are reinforcing elements and the matrix is made up of this cement and other mixture. This is the best application of concrete. The quality of your beam or pillar depends upon, or not quality, strength of your beam, pillar depends upon strength of the rods which are used in that beam or pillar. So in composite materials, whatever material inside you are putting in the matrix is called as reinforcing agents. They are either in the form of rods, powder, particle, maybe nets, in this way. So net means jalidar asta. So in that case, you might have seen some glasses where some net-shaped or metallic sieves are there. In Marathi, we can say tarechi jali aste. आणि बाहेरून आणि आतून काच असते. सो इट इज कॉल्ड एज अ नेट शेप reinforcement. So net shape reinforcement rods, blocks, particles, etc. are used as a reinforcing shapes of different material, which provides the strength to the overall composite material. One of the best application is FRP. FRP is long form fiber reinforced plastic. You might have seen this FRP anywhere. It is called as fiber reinforced plastic. Fibers are nothing but your threads, your cloth. So best area used for roofing purpose. In our college also, whenever after lockdown we will join the college, our canteen, main central canteen, at the top or whatever roofs are made, these are from FRP sheets, green in color. So if you get opportunity to see the piece of that roof, you'll find outer both the sides, inner as well as outer side, are made up of plastic, and in between there is a greenish cloth. Cloth is actually fiber. What happened with fiber? The strength of that plastic is improved like anything. It is proved. Mechanical testings and other characteristics are checked after making the composites. And then the people came to conclusion that composite materials provides best strength. Composite materials provides best strength and with less weight. Stiffness is one of the property. So now see load per unit deflection. This is the definition of stiffness. So if you take any of the metal rod and if you measure its stiffness, and if you take any of the composite rod and if you measure stiffness, many times you find same stiffness. Metal rod stiffness and composite material stiffness you find same, but metal rod's weight, because it is made up of steel, it is heavy, and this composite material is usually made up of epoxies and plastics and other similar materials. So epoxies, plastic and similar materials are having very less weight as compared to steel, but both are giving same stiffness. That's why composite materials find wide applications and importance in industrial sector and automobile sectors. Once again, I'll repeat my statement. Even if you Google the composite material, you find lot of material. Currently also, many of the students are performing their master degrees, PhDs on composite materials. So here, there are different types of composite materials. As far as your curriculum is concerned, we'll concentrate what are the general guidelines about the composite and what are their types and what are their applications. So only this area is to be covered in the composite material as far as your part. So I have given, I will explain the types also. Just overall idea I have given about what is meaning of composite. I repeat, I will dictate the definition, don't worry. Composite materials are mixture of 2-3 elements, layer over layer, no problem, 2 layers, 3 layers, 4 layers. So composite materials are mixture of 2-3 layers of 3-4 or more elements, and they are added at macroscopic level and having good strength as compared to the regular metals and alloys. Just write down. Composite material is made up of 2 or more constituents, 2 or more constituents with different physical and chemical properties, different physical and chemical properties, and characteristics of the composite material is different than individual component. Next line, next star mark. Composites are having less weight and better stiffness. Example, concrete mixture with steel reinforcement, concrete mixture with steel reinforcement. Second, FRP, fiber reinforced plastic. Next line. Strength of the composite material depends upon strength of the fibers oblique reinforcing agents. Next line. Composite materials are costlier. Make underline. So definitely you are going to add, you are going to do some process, some cost of process is added. But if you compare the strength to weight ratio and characteristics, composite materials are having more durability than other elements. Composite materials are costlier but gives better strength, better stiffness, and less weight. Applications: aircraft industries, automobile parts, partitions, furniture, doors, windows, panels, etc. So our CAD/CAM lab 2, you have seen it is having glass partition. I don't know whether you are remembering. Once you will come to department, you please see carefully. The glass of CAD/CAM lab is composite material, where outside layer, inside layer is glass, and in between there is a net of wire, metallic wire. So once there will be breakage of the glass, that breaking into pieces will not be there because of that reinforcing net, and it will provide the additional support and strength to the only glass. Okay, even if glass of your vehicles and automobiles are having thin layers, that is also composite material. That's why there will not be break into pieces in case of accidents. Next slide. Types of composites. First, fibrous composite material. Fibrous composite material. Means there are fibers like threads. Okay. We have our R&D lab where composite parts are prepared. Once you will be here, just request me, I will show you that some of the parts of the composite area, as well as whatever epoxy is used, what are fibers. So natural jute, maybe your artificial glass fibers, everything is used as a reinforcing agent. Natural fibers as well as artificial fibers. Then laminated composite material, second. Means there are layers A, B, A, B in this way. These are called as laminate composite layers. Fibers means threads. Okay. So instead of steel rod, if you just put the threads, that will become fibrous. So your FRP is fibrous. That's why fiber transports plastic. Next, third, particulate. PARTICULATE, particulate in bracket, particles in the matrix. Particles in the matrix. And fourth, combination of above. Next line. Usually, the epoxy material, epoxy is one type of plastic. Usually, epoxy material with natural fibers and artificial fibers is used as raw material. So epoxy is matrix. So if you want to produce the composite material, take some epoxy which is in liquid form, and you have to take one mold, casting operation. So in that mold, you have to put your threads as per your requirement. Again, further investigations and further research is going on. What is the diameter of that fiber? What is the inclination of that fiber? How many fibers together you are going to put? Whether you are going to put at 45 degree, 90 degree or 0 degree or 180 degree. Accordingly, you have to arrange these fibers and just pour that epoxy in it. If you pour it, it will solidify after a few minutes or hours. And whatever you will get, that will be your composite material. So only epoxy, if you use, its strength will be less. And if you use that epoxy with the natural or artificial fiber, you will find the strength has increased. So you have to check the strength. Strength may be checked on mechanical testing machines, maybe hardness testing, universal testing machine, bend machine, shear machine. So different machines are available where the mechanical testing is carried out. We have chapter number 6. There you'll understand what are the different mechanical tests. So this is about composite. If you want more information, you can just Google it and check. But for getting 3 marks or 4 marks, whatever required, I have dictated, and you can prepare the notes accordingly. Okay. Now this is all about composite material. Next part is nanomaterials. Write down. Now you might be knowing nano means how much lower scale you can go below the meter. 1 meter equal to 1000 millimeter. 1 millimeter equal to 1000 micron. And 1 micron is equal to 1000 nano. So 10 raised to minus 9 meter. Remember, 1 meter equal to 10 raised to 3 millimeter. 1 millimeter equal to 10 raised to 3 micrometer. And 1 micrometer equal to 10 raised to 3 nanometer. This much small scale. So nanomaterial means not like your material is not visible to you. Not like that. So how the nanomaterials are defined? The definition of nanomaterial itself is nanomaterials are the materials in which at least one dimension is around 100 nanometers. 100 nanometer. If you are one of the dimensions, length, breadth, height, whatever may have. So out of that, one dimension should be less than 100 nanometer. Such materials are called as nanomaterials. Nanomaterials means not materials whose size is 10 raised to 10 raised to minus 9 meter, and they are not visible. Not like that. Now, why this concept came? And there are engineering nanomaterials, natural nanomaterials. So best example, before we go to study, here also same thing. This is a way you can write 100 pages on nanomaterial and you can write 1 page on nanomaterial also. So there is no limit. The thing is, you have to understand the concept, and accordingly you have to write 1 paragraph so that you can get 3 marks or 4 marks. But we are not here only for getting 3 or 4 marks. We are here for understanding the concept. You have seen what are the how this concept is launched so that your parts are made accordingly. You might have heard wrinkle-free shirts or dust-free walls, dust-free colors, anti-dust walls, maybe anti-dust cloth. Even you put a bucket of water on your shirt, there is not a single droplet of water will make your shirt wet. You might have heard this. So what is the principle behind it? You might have seen the leaf of the lotus, Kamalacha pan. If you put the droplet of water on it, what happened? That droplet of water will not touch to the leaf. Why? Because if you see at below microscope, the leaf of lotus have very small threads, and these threads will hold that water droplet at their tip because they are thousands in number, and it will not allow to touch at the bottom of the leaf. So it is called as surface area. Because of these thousands of threads, surface area has increased. So same thing. What is the difference? See, have you heard? You just Google. Nowadays, people or technocrats are making the invention. You know the simple thumb rule: gold, yellow color; silver, white color; then copper, red color. These concepts you are knowing as a thumb rule. Your ancestors have shown you. You have also seen by your naked eyes. But are you knowing? Nowadays, people are working on it so that at microscopic level, at nano level, if you make some changes, you may have your gold in the blue color. You can't imagine that this is a gold. How natural color of gold, which is which is yellow, converted into blue. This is at atomic level, 10 raised to minus 9 meter. So 10 raised to minus 8 is an angstrom unit. So quantum effect changes. So little physics you have to study in that case. You have to go in the physics. So physics means quantum effects. So at nanoscale, the quantum effects changes which may cause this change in the properties, physical properties of the material. Okay. So nanomaterials are nothing but the materials in which at least one dimension is less than or equal to 100 nanometer. And this find applications everywhere in cosmetics, glasses, colors, clothes, ornaments, everywhere this concept has been used so that the surface area is changed and then you may got improved properties. These nanomaterials are also have different shape as like composite material. 0D means particle, 1D means rod or thread, 2D means plate or net, 3D means block. So at different shapes, these materials are available. Okay, right on. nanoscale materials are defined as set of substance. Nanoscale materials are defined as set of substance where at least one dimension, at least one dimension is less than 100 nanometers. Nanomaterials, next line. Nanomaterials are of interest because at this scale, unique optical OPTICAL, magnetic, electrical and other properties emerge. Means what? So if you take any of the part, maybe at your normal scale, so maybe you have some different shape. So at this scale, if you take that part, that have some magnetic property, that have some electrical property, that have some optic property. But if you make small and small and small piece of it, you find different quantum effects, different optical effects, different magnetic effects. That's why emerge means you can say they are going to be elaborated. The properties which are not available at large scale that can be observed at lower scale. अधिक उफाळून येणे. Next, it gives great impact. It gives great impact in electronics, medicine, and other fields. Next slide. Two main reasons why nanomaterials, don't write nanomaterials, only write materials. Two main reasons why materials at nanoscale have different properties. म्हणजे दोन कोणती कारण आहेत की ज्याच्यामुळे नॅनोस्केलला वेगळ्या प्रॉपर्टी आहेत. Two main reasons why materials at nanoscale have different properties. Next line. First, increased relative surface area. Increased relative surface area. And second, new quantum effects. New quantum effects. Next line. Nanomaterials found applications in sunscreens, glasses, cosmetics, sport goods, stain resistant clothing. STAIN, resistant clothing, comma, electronics and medicine. Next line, last point. Classification of nanomaterials. First, 0D, 0D, spheres and clusters. In this way, right? 0D. Second, 1D, 1-D, nanofibers, wires, rods. Third, 2D, films, plates, network. And fourth, 3D, block. So friends, this is all about nanomaterials. Nanomaterials finds application in variety of parts, and as I told, in variety of areas, electronic application, medicine applications, and all other applications where the effects at the that nano level changes. So there are two reasons I told why they have different property. It's at nanoscale they have different quantum effect, okay, and increase the relative surface area. That's why the nanomaterials find applications in industries and day-to-day life. So if you write short note in this way, you can little elaborate, you will get 3 out of 3 marks. Okay, this is all about nanomaterials and composite materials. So this will be these are the contents of today's lecture. In next class, we are going to start with heat treatment chapter. Okay, those who have not submitted the test, still I will give one more day. Please submit it, so that in next class I will give next assignment. Thank you very much. Hello, Mr. Onkar Pawar. Please leave the lecture. Mr. Onkar Pawar. झालं सगळे जण होते ना.